In this question, they are talking about 6 cross 6 square. We have enlarged form over here. The grid points or the intersection point they are naming from A1 to A49. You can do in any order. Let's do it in particular order A1, A2, so on. This would be then A8, and then if we keep on naming it, the last one would be A49. Now they are saying AI and AJ are friends if they are adjacent. Now the 2 points can be adjacent along a row or along a column. For instance, let's check out A1. A1 has two friends, namely A2 and A8. Similarly, A7 will also have two friends, namely A6 and A14. This name would be A14. What else? If you look at, let's say, A4, A4 will have three friends, A3, A5, and whatever is this point. This point is A11. Similarly, if I start looking for friends of A11, it will have four friends, namely, this is A10, this is A12, A4 of course, and whatever is name of this point, A11 has four friends. Now let's look at the question. Two distinct points are chosen randomly out of all these points. Every point has equal chance to be chosen though. Now they are asking what is the probability that they are friends. Two randomly chosen points are friends. You want to find that probability. Now what do? Of course, you start choosing points. So now you already have seen that the points are falling in three categories. Either you have two friends, or you have three friends, or you have four friends. So, namely, if you are choosing a corner point or you are choosing an edge point which is not a corner or you are choosing an inside point, the point can be categorized into these three categories. And why we are doing so? Because probability of choosing this is different. What is the probability that you choose a corner point? Since there are only 4 corner points out of 49 points, the probability that you choose a corner point would be 4 over 49. Similarly, what is the probability that you choose an edge point which is not a corner? There are 5 here, 5 on each side. So there are 20 such points out of 49. So you get 20 over 49. What is the probability that you choose an inside point? How many inside points do you have? 1, 2, 3, 4, and 5. And similarly, 1, 2, 3, 4, and 5. There are 25 such points. So probability that you choose a point which is inside, it's this. Then next comes that you start choosing the second point. What is the probability that the second point is a friend if you have chosen a corner point? Of course, the corner point has only two friends. So the probability that the next chosen point will be a friend would be 2 upon the remaining points, because one point you have already chosen, that's a corner point. So 2 over 48, that the second point would be a friend. Now similarly, if you have chosen an edge point, then what is the probability that the second one will be a friend? The edge point has three friends. So of course 3, and total points available to you are 48. So 48. Similarly for the last one, what do you think? The total number of friends an inside point has is 4 divided by the total number of available points. So now you have to just work this out, because now the probability that both are friends would be the product of these two probabilities. Let's do that. 4 over 49 times 2 over 48. So basically we are using the total probability law, but we have made our job easier by drawing this tree, which is quite understandable, and of course we can finish this off in a minute. Okay, what next? Now they are asking what is 7 times p. This is p, right? Probability that pf is nothing but p. Now they are asking what is 7 times p. Let's multiply this by 7. 49 over 48 I can take outside. 49 into 48. And what is inside is 8 plus 60 plus 100. So you end up in getting 7 into 168 divided by 49 times 48. So you end up in getting, this is how much? 7, 24, and then 2. So half. So 0.5 is the value of 7p. Okay, I will see you soon with another question.